Hey there, glad you can make it for the second video for section 1.4, which is about rewriting formulas and equations. We focused on the formulas part, rewriting formulas, in the first video for this section. Now we're going to focus on rewriting equations. Now, let's read the goal, and I'll be a little more specific then. You will be solving literal equations for specified variables. Now, a literal equation isn't an equation that you solve and you're like, oh my goodness, I literally solved an equation there. Not what I mean. What I mean by a literal equation is something like you see in this example right here. A literal equation is just simply an equation that has multiple variables in the equation. Alright? Now, a literal equation doesn't have to have any numbers at all. And you're going to see some examples like right here, for instance, in the second one we're going to work out, where there's no numbers at all within the equation. Those are examples of literal equations. Now, the formulas that we were solving were actually literal equations as well. So we've already talked about the skills involved with solving these literal, easy for me to say, equations. All right. Difference here in this video being a couple things. First of all, the variables in these literal equations don't have to represent anything like they did in the formulas. Like an F in the formulas would represent Fahrenheit or force. You know, an M could be mass. All right, X and Y are just really X and Y. They can represent something, but they don't have to represent anything in a literal equation. Okay, and then secondly, the difference in this video is that we are going to increase the difficulty level of some of the literal equations that we're working with as well. So there you go, two kind of reasons to have this video, even though we already have the basic skill set. All right, let's go ahead and get into this example. It says we're going to solve 9x minus 4y equals 12 for y. And then we're going to find the value of y when x equals negative 12. All right, now let's go ahead and rewrite the equation. Or you're copying it down the first time, I'm rewriting it. And as I told you in the last video, it's often helpful to make sure that you identify which variable it is that you're actually trying to isolate. We're trying to isolate the y, so I'm going to highlight that. And that'll become more helpful as we go through some more difficult examples if you'll do that. Now, we need, in order to solve for y, to isolate that y, and that means we need to get first of all, every term that doesn't have a y to the opposite side of the equation. Now there's two terms on the side of the equation where our y is currently located. That's the x term and that's the y term, and we need to cancel out this x term from this side of the equation and move it to the opposite side of the equation. Well, the way we'll cancel out that quantity of positive 9x is we'll subtract 9x from both sides of the equal sign. All right, so let's think about what the result is. If you subtract 9x from the left side, 9x minus 9x is 0, and you still have the negative 4y. Don't forget that negative sign. The subtraction sign in front of the 4y implies that this is a negative term. And then you can't actually subtract 9x from 12 without knowing what x is. They're not like terms, so we'll just write 12 minus 4x, or actually 9x, on the right side of the equation. All right? And then there's one more step to getting y by itself. We've got to cancel out the coefficient. So getting that by itself. We've got to cancel out the coefficient. And so we'll divide by negative 4. Now, negative 4y divided by negative 4 is just positive 1y. On the right side of the equation, when we divide this by negative 4, we need to make sure we divide each term by negative 4. That's basically the distributive property with division, if you will. All right? 12 divided by negative 4 is negative 3. Negative 9x divided by negative 4 is going to give you positive, because a negative divided by a negative is positive. And then we'll just say 9 over 4x. All right, there you go. So we were able to solve that equation for y. That was the first step of this problem. And we would be done with that first step, but I do want to show you something that I hope you've already made the connection with. And if you haven't, I want you to make the connection. Really what we did here was we took a linear equation and we changed it from standard form into slope-intercept form. But you'll recognize it more as slope-intercept form if I go ahead and switch these two terms on the right side of the equation. Y equals 9/4 x minus 3. So it would make it easier, for instance, to graph an equation like this if we're able to write it in this form right here. Hopefully you remember that, which is something we'll do quite a lot of in the next chapter, as a matter of fact. All right, now the second part of this problem was let's find the value of y when x equals negative 12. So we'll substitute, just like what we were doing with the similar problems with formulas. We can replace the x with negative 12. And I keep making these problems have nice numbers because I want you to get used to doing canceling with fractions. For whatever reason, people forget that skill or overlook it whenever they're learning their multiplication with fractions when they're younger. All right, so 9/4 times negative 12. The negative 12 and the 4 are both divisible by 4. 4 goes into itself once. 4 goes into negative 12 negative 3 times. And now we can go ahead and finish up and figure out what y is. We're going to have 9 times negative 3. Now be careful with your signs here. That's going to be negative 27. And then negative 27 minus 3 is going to be negative 30. So there's your second answer for this problem. Right? Same basic thing that we were working on the last time. Let's look at some more examples here. And this, as I showed you a little bit ago, is a literal equation that doesn't have any numbers whatsoever. Now, after we solve this equation for a, we're going to try to find a for specified values of b, c, and d, but the equation itself has no numbers in it, right? Okay, well, let's copy down the equation. And let's make sure we know which of the variables we're trying to solve for. It's that a right there. Now, this is going to be a problem that you'll run into from time to time where the variable that you're trying to isolate is kind of trapped by a grouping symbol. And you might say, where's a grouping symbol? Well, in this case, the fraction bar is a grouping symbol. The numerator is one group, and the denominator is another group. And our a is trapped in one of those two groups. Before I can get the a out of that numerator group, I'm going to need to get rid of that fraction bar. So the first thing that I'm going to do here is try to cancel out the denominator. And I can do that if I will simply multiply both sides of the equation by the denominator. I'm going to show you that step where I normally would not. We're multiplying both sides of the equation by the denominator, so we'll group the left side of the equation in parentheses, multiply it by the denominator, and we'll multiply the right side of the equation by the denominator as well. And so what happens then is that, so use your rules for canceling out the fractions, c goes into itself once, and so both of these will become 1s, and you're left with 1 times a plus b on the left side, which is just a plus b. And on the right side of the equation, you're just left with c times d. Now, we got the numerator group separated from the denominator group, and now we're going to be able to separate the a term from the b term simply by subtracting b from both sides. So, a is going to equal c times d minus b. That's part 1 of the problem. And now that we've isolated the a, it's going to be very easy to figure out what it is for these values of b, c, and d. Let's go ahead and plug those in. A will be equal to c, which is 10, times d, which is negative 3, minus b, which is a positive 3. And so that'll give us negative 30 minus 3, which is negative 33. There's the second part of the problem. We've responded to both of the things that were asked of us there. All right. Not too bad, right? Let's keep on going. And I'm going to shorten the next couple problems in a sense where I'm not going to ask you to plug in certain values of variables after you've gotten one of the variables by itself. Here you can see I'm just telling you to solve for x. I'm not going to ask you what is x when a is this and b is that. But I have made the problems itself, the actual isolation of the x, a little more difficult. And the reason it's more difficult is because you've actually got two different places where that x is located here. Here's the example we're about to work on. Same is going to be true in the next example where we're going to be solving for y. And you're going to see that the y is located in a couple different places. So there's going to be strategy involved with how do we get the x by itself when there's x is located in two different places. Well, copy the equation down. All right, and here the variable we're trying to isolate, I said, is located in two different places. So what's our strategy going to be? Well, whenever you have the variable you're trying to isolate located in multiple locations, the strategy changes slightly in this respect. What we want is every term that has an x in this case to be on one side of the equation, and every term that doesn't have an x is going to be moved to the opposite side of the equation. So, what I would like to do is I would like to get both of the x's either on the left side or the right side. And let's go ahead and start with that. I'm going to cancel out this cx, the x's on the right side of the equation, so that I only have x's on the left side of the equation. And I'll do that by subtracting this entire term, cx, from both sides. Okay, now I'm going to try to group things. We're going to have ax, and since the ax and cx are going to be like terms here, I'm going to go ahead and put the minus cx there. We're subtracting cx from that side, and we'll still have the plus b for the moment. And on the right side, when we subtracted cx from there, Of course, the CX is canceled out, and you're left with D. All right. Now, this is like having all the variable terms on the same side of the equation, and you want all the constant terms, which the B and the D are in this case, to be on the opposite side of the equation. Again, this is what we're trying to isolate. Let's get every term without an X to the opposite side of the equation. We'll do that by subtracting B from both sides. So that'll leave us with AX minus CX over here equals D minus B on the right side of the equation. Good. We've kind of accomplished part of what we needed to. We've got every term that has an X on one side of the equation, every term without it on the opposite side, as I've said many times now. Here's the next thing. We're going to have to use some kind of trick in order to get it down from having two terms with an X to only having a single X. And what we're going to do here is we're going to take advantage of the distributive property, but we're actually going to be undistributing, or more commonly known as factoring. You notice that these two terms have X as a common factor, and the way we're going to get it down to a single X is we're going to factor that X out of these two terms. All right, so when we factor X, you have to think about what do you multiply X by to get AX, and that would be A. And what do you multiply X by to get a negative CX? Well, that would be a negative C. All right, does that make sense? You can see if I distributed X times A minus C, how I would get what I had previously. So X times A minus C is equal to D minus B. And then basically, this whole thing right here, this A minus C, is like my coefficient. It just happens to be written behind the X. But I have X times this quantity. If I want to isolate the X from this quantity, I've got to divide both sides of the equation by that quantity. So I'm going to divide both sides by A minus C. And so on the right side, that's going to look like this. We'll take the D minus B and we'll divide it by A minus C. Looks complicated, but the idea was let's get all the variables on one side of the equation, and then let's factor in order to get it down to only a single X. All right, remember that, because we're going to use that in the process for the next problem as well. One more to try here in this video. Copy that down, please. And you see we're trying to solve for y, and there's a y on each side of the equation. Now, just like before, we want all the terms with y's on one side of the equation. But a little added difficulty here, these y's are both trapped inside of grouping symbols, aren't they? I can't just move this y to the left side or this y to the right side right now because they're trapped inside of grouping symbols. So we got to figure out how do we get them out of grouping symbols. And in this case, it's going to be a little bit nicer for us if we'll go ahead and distribute the p on the left side and the r on the right side. So you'll see how this works. So on the left side, distribute that p, and that's going to give you p times y minus p times q. And on the right side then, you're going to have r times y minus r times s. Now this is essentially like the previous problem at this point, in that we've just got two terms on each side of the equation, and on each side we have one term that has a y and one term that doesn't have a y. Alright, so get the terms with the y's to the left side, get the terms without the y's to the right side. Let's see if we can do this actually in one step here. I'm going to subtract ry from both sides so that all my y's are on the left side. So I'll have a py minus an ry. And on the same step, let's go ahead and add pq to both sides so that I have every term without a y on the right side of the equation. If I add pq to both sides, I can either write it as negative rs plus pq, or I prefer actually to write that as pq minus rs. Hopefully you can see how those are equivalent quantities. Okay, and then do you remember what to do from the previous problem? Hopefully you're saying that we have a y as a common factor for these two terms over here, and we're going to factor that y out of there to get down to a single y. Alright, so factor a y out of the left side of the equation. That'll leave you with y times p minus r equals pq minus rs. And then, since we have y times this quantity, we can isolate the y by dividing by this quantity. We're just going to have y equals the right side of the equation, pq minus rs, over the difference of p and r. Alright, so that's solving literal equations. Idea is pretty simple. Some of the problems get a little complicated to see, but it's something that you're going to be able to handle. Thanks for watching, guys. See you next time.